Welcome to the session 3 of Fluid Mechanics, Unit 2, Fundamentals of Fluid Flow, Kinematics. Fluid kinematics is a study of flow of a fluid which is in motion, considering the pressure forces which are responsible for the motion of the fluid. Okay, and the fluid motion can be analyzed by two approaches called Lagrangian approach and Eulerian approach. In the first approach, that is Lagrangian approach, a fluid particle is identified and followed during the course of its motion with time. To know for example, to know the attributes of the vehicles to be purchased, we have to follow the specific vehicle in the traffic flow all along its path over a period of time. But it is very difficult to trace the fluid particles, making it nearly impossible to apply the Lagrangian approach. So one more approach is developed, that is called Eulerian approach. According to this approach, observing in this approach, it consists of observing the fluids by setting a fixed station or a section in a flow field. The motion of the fluid is specified by velocity component, which is the function of space and time. This is considerably easier than the previous approach, that is Lagrangian approach. For example, observing the variation of flow property in a channel like velocity, depth, etc. Next is velocity. Velocity of a fluid is defined as the rate of change of displacement of the fluid along the direction, and it is denoted by the letter U, which is equal to dx by dt, where dx is the distance traveled by the fluid element and dt is the time taken. Velocity of a fluid element is a vector quantity and it is a function of space and time. The resultant velocity of a fluid along any direction and u, v and w be the velocity components in x, y and z direction. So mathematically we can write the velocity components as u is equals to f of x comma y comma z comma t. Similarly, we can write the velocity component v as well as u. Next is acceleration. Acceleration of a fluid element is defined as a rate of change of velocity of a fluid along that direction. Ax, Ay and Az are the component of acceleration along x, y and z direction respectively. Mathematically, the acceleration is represented as, if we consider the direction as x, so Ax will be equal to du by dt. We know that u is a function of x comma y comma z comma t. Hence, Ax can be written like this by partial differentiation. Okay. Similarly, we can write the equation for Ay as well as Aw. Here, we know u is equals to dx by dt, v is equals to dy by dt and w is equals to dz by dt. See, in this above expression, this is repeated here, the above expression, the last term, that is the time term, du by dt, dv by dt and dw by dt is called as local acceleration. The remaining thing is called as convective acceleration. Next comes to types of fluid flow. In that first one, steady and unsteady flow. A flow is said to be steady if the property of the fluid and the flow does not change with time. Okay, at any section or point in a fluid flow. So dou P by dou T will be equal to 0. Similarly, a flow is said to be unsteady if the property of the fluid and flow changes with respect to time at any section or a point. So which is given by dou P by dou T will not be equal to 0. Next, see in this figure, we can see, here, next is uniform and non-uniform flow. A flow is said to be uniform if the property of the fluid and the flow does not change with direction over a length of flow along the flow at any instant. So we can take it as dou P by dou X will be equal to 0. A flow is said to be non-uniform flow if the property of the fluid and flow changes with direction over the length of flow considering along the flow at any instant. So dou P by dou X is not equal to 0. In this figure, we can see the various types of fluid flow. At the section 1 and 2, the flow is said to be uniform because the property of the flow is not changing between the section 1 and 2 at any instant. Here y1 will be equal to y2, v1 will be equal to v2. Similarly, if you consider the section between 2 and 3, so we can classify this flow as non-uniform flow. Here you can see there is the property is varying here. Okay, the y2 will not be equal to y3. It is slightly increasing here. Similarly, v2 will not be equal to v3. Again, this non-uniform flow is classified into two types, that is gradually varying flow and rapidly varying flow. So between section 2 and 3, we can observe the flow changes, flow property and fluid property changes gradually. Okay. Whereas between the section 3 and 4 and 5, you can see the properties of fluid and flow are changing very rapidly. So this comes under rapidly varied flow, which is a type of non-uniform flow. So the combination of steady and unsteady flow, uniform and non-uniform flow can be classified as steady uniform flow, unsteady uniform flow, steady non-uniform flow, and unsteady non-uniform flow. That is between the section 4 and 5. In section 2 and 3, it is steady non-uniform flow. In section between the section 1 and 2, it is a steady uniform flow. Next type of fluid flow is 1, 2, and 3-dimensional flow. A flow is said to be one-dimensional if the property vary only along one direction and will be constant with respect to other two directions. Next is a flow is said to be two-dimensional if the property vary only along two directions and will be constant with respect to other direction. The last one, the flow is said to be three-dimensional if the property vary all along all the directions of the three-dimensional axis system. Next is laminar and turbulent flow. When the flow occur like a sheet or a laminates, the fluid element flowing in the layer does not mix with the other layer, then the flow is said to be laminar. So if the Reynolds value is less than 2000, we can classify the flow as laminar flow. When the flow velocity increases, the sheet with like structure or sheet like flow gets mixed with the other layer and flow of the fluid element become random, causing turbulence, and also there is a generation of eddy currents and flow reversal also takes place. So this type of flow is called as turbulent flow. So if the Reynolds number is greater than 4000, then we classify the flow as Reynolds flow. If the Reynolds number value lies between 2000 and 4000, then the flow is classified as transition flow. Next type of flow is compressible and incompressible flow. A flow is said to be incompressible if the density of the fluid does not change along the flow direction. And in case of compressible flow, the density varies along with the flow direction. Next comes to rotational and irrotational flow. A flow is said to be rotational if the fluid element rotate about their own axis when they move along the flow. And the flow is said to be irrotational if the fluid element does not rotate along their axis uh, along the flow direction. Next is path line. It is a path traced by the fluid particle over a period of time during its motion along the fluid flow. Next is streamline. It is an imaginary line. When the tangent is drawn at any point, it gives the velocity of the fluid particle at that point. Straight lines. It is an imaginary line that connects all the fluid particles that has gone through a point or a period of time in a fluid motion. Next is stream tube. It is also an imaginary tube formed by streamlines on its surface in such a way that the flow only enters the tube from one side and leave it on the other side. No flow takes place across the stream tube. Thank you.